Normal random variable. The normal distribution. A bell-shaped curve commonly illustrates that a given set of data is in normal distribution, where the mean, median, and mode are equal. These are the characteristics of a normal curve. First, the curve is a bell-shaped and has the highest peak at the center of the distribution. The mean, median, and mode are equal and clustered at the middle of the distribution. It is symmetrical about the mean that divides the curve into two equal regions, 50% from the left of the mean and 50% from the right of the mean of the distribution. The curve is continuous on both sides and it does not touch the horizontal axis. The total area under the normal curve is 1 or 100%. Empirical rule. For a distribution that is symmetrical and bell-shaped for a normal distribution, approximately 68% of the data values will lie within one standard deviation on each side of the mean. Approximately 95% of the data values will lie within two standard deviations on each side of the mean. Approximately 99.7% or at almost all of the data values will lie within three standard deviations on each side of the mean. The illustration of the area under a normal curve. So you have observed that there are 68% of the data values within one standard deviation about the mean. Then we have 95% of the data values within two standard deviation about the mean. And lastly, we have 99.7% of the data within three standard deviation about the mean. So we will use this illustration to determine the area under the normal curve. Example 1. Find the area under a normal curve with a mean mu is equal to 50 and standard deviation sigma is equal to 5. Between 40 and 55, or 40 is less than x, but x is less than 55. Between 55 and 65, or we can also write this as 55 is less than x, but x is less than 65. Below 45, or x is less than 45. Above 35, or x is greater than 35. Below 55, or x is less than 55. To find the area under a normal curve, we need to first identify the given values, since the mean is 50 and the standard deviation is 5. Now let us create a normal curve. So since the mean is already given, so we will put this at the middle of the distribution. So we have the mean is 50. Then we will now identify the one standard deviation about the mean. So we will start with the one standard deviation above the mean. So we have mu plus sigma. Then substitute the given values. We have 50 plus 5. The result is 55. Then we will write this in our normal curve. So that is our one standard deviation above the mean. Then let us now identify the value of one standard deviation below the mean. So we have mu minus the sigma. Substitute the values. Then the result is 50 minus 5 is 45. So we have now one standard deviation below the mean, which is 45. Now let us proceed to two standard deviation about the mean. So let us start with the two standard deviation above the mean. Then substitute the values. So we have 50 plus 2 times 5. The result is 60. So we will write 60 sa 2 standard deviation above the mean. And we have also 2 standard deviation below the mean. Then substitute the values, simplify, then the result is 40. So we have now 40 as our 2 standard deviation below the mean. So let us now proceed to the 3 standard deviation within or about the mean. So let us start with the 3 standard deviation above the mean. Substitute the values, simplify, the result is 65. Therefore, 65 is the 3 standard deviation above the mean. And the 3 standard deviation below the mean, we have mu minus 3 times sigma. Substitute the values, simplify, the result is 35. Therefore, the 3 standard deviation below the mean is 35. So we have now these values. And we can now answer the given problems. Since we already have the illustration of the normal curve, then we will now answer A. To find the area between 40 and 55, so let us check our normal curve. So we have 40 to 55. So you have observed that we only need to add all the region between 40 and 55. Since we have 13.5%, 34%, and 34%. Then the result is 81.5%, or we can also write into decimal form. So the decimal form of 81.5% is 0.8150. The area between 55 and 65. So let us now check our normal curve. So 55, 65. So you have observed that the area under or between 55 to 65, we have 13.5 and 2.35. And if we're going to add this, we have 15.85% or 0.1585. Next, the area below 45. So we're going to check all the areas below 45. So in this given illustration, we have the following regions or areas. So we have 0.15% plus 2.35% plus 13.5%. So if we're going to add this, we have 16% or 0.1600. Then the area above 35. So let's go back to our normal curve. Okay, so since it is above 35, so based from our illustration, we have these areas. So let us start with 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. So the result we have 99.85%, or it is equivalent to 0.9985 in decimal form. Then we have the area below 55. So these are the region under the below 55. So we have 0.15% plus 2.35% plus 13.5% plus 34% plus 34%. The result is 84%, or that is equivalent to 0.8400. Example 2. In Matina Aplaya, it was observed that the incubation period of sea turtles is normally distributed with a mean of 50 days and a standard deviation of approximately 3 days. If 800 eggs are being incubated, how many turtles do we expect will hatch? A. In 53 to 59 days. B. In 47 to 53 days. C. In 50 days or fewer. Assume all eggs eventually hatch. Let us now create a normal curve distribution. So since it is given that the, the mean or the average of incubation period of the sea turtle is 50 days. So we will write the 50 days at the middle of the distribution. So we have 50. And a standard deviation is already given, which is approximately 3 days. Therefore, the one standard deviation above the mean is 53. Then, the one standard deviation below the mean is 47. The two standard deviation above the mean is 56. While the two standard deviation below the mean is 44. The three standard deviation above the mean is 59. And finally, we have the three standard deviation below the mean, which is 41. So since you already have the normal curve distribution, so let us now answer letter A. Okay, to find the area between 53 to 59. So let's go back to our illustration. So the area between 53 to 59. So we have 13.5% and 2.35%. So if we're going to add this, we have 15.85%, which is equivalent to 0.1585 in decimal form. So to determine the number of turtles that will hatch between 53 to 59 days, since there are 800 eggs, we will multiply the resulted area, which is 0.1585 to 800. So 800 times 0.1585, the result is 127. So therefore, there are 127 eggs that will hatch between 53 to 59 days. Letter B. The area between 47 to 53. So let's now check. We have 34% and 34%. So if we're going to add this, the result is 68% or 0.6800. Okay, to determine the number of eggs, we'll multiply the result to 800. So 800 times 0.68, which is equivalent to 544 eggs. So there are 544 eggs that will hatch between 47 to 53 days. So let's proceed to letter C. So to find the area below 50 days or in 50 days or fewer, so let's go back to the normal curve distribution. So it means that from 50 and below, we will add all the area of the curve. So we have 0.15% plus 2.35% plus 13.5% plus 34%. So we have 50% or 0.50. So the number of eggs will multiply 0.50 to 800. So there are 400 eggs that will hatch or that we will expect to hatch in 50 days or fewer.